So as you do the homework, there will almost always be at least one or two homework problems that aren't exactly in the format or something that you're used to. It's just kind of pushing you a little bit to see if you can apply the same exact idea to a little bit different situation. If you're only having trouble on those kind of problems in the homework, you're in a pretty damn good place. Right? And even if you get a homework problem wrong, I grade much more heavily on concept understanding than I do on getting the right answer. We're not in the real world yet. If you get the wrong answer, nobody dies. Right? What's more important right now is, do you understand how to try to get the right answer? Once you're out in the real world, somebody hires you, you better get the damn right answer too. Right? Yeah?
Along that same idea, like during tests, do you give partial credit, or if it's wrong, it's wrong? Like, if you understand the idea, you get the...
If you ever have a math teacher that grades by Scantron, they are not a math teacher. End of story. So this basically I just said I grade heavy on concepts. So if I have like a 5-part problem, this is what I always hate. You have a 5-part problem, the first part you screw something up. Some stupid little thing. And then every other part after that then is wrong.
Like a negative.
And I have teachers that would be like, 0 for the whole thing. Screw you, man. So if you make a mistake up on step 1, as long as you do all the algebra correctly after that, I'm going to take off something, but not like a lot. You guys with me? So that's why it's important. 2 reasons to show me the work. Number 1 is, if you do something wrong, you didn't show me a damn thing, I'm taking off all the points. Because I don't know what the hell you did. Right? And number 2, I need to see your work, because I need to see how you think about how to do problems. All right, cool. Yeah?
Can you use calculators on the test?
Yes, but you still must show me the work. Now, when I say that, you don't have to divide 1.3 into 87.6. This is not Math 88, right? But I need to see the steps of solving an equation. And the last step you could do in the calculator, 17.8 divided by 27. I don't need to see that. You kind of with me? So you got to show me the work, but then you can use the calculator for stuff like that. Okay, cool. Back. The most basic form of factoring is this guy here. Somebody factor that for me.
Take out y.
I love it. So it's GCF, greatest common factor. And what is that GCF?
4y.
4y. I love it. So you look at the numbers, and then you look at each letter. And why don't you take out y squared?
Because I just have
Because the first dude always got 1y. It's not fair. Right? So if I try to take out 2 y's, he'd freak out. So what's left? Good. This first guy took the 4 and the y, so the next left?
7.
7.
Y.
And he had 2 y's that took 1. All right, so that's not a big deal. Right? And notice how I put that offset a little bit? I almost always have somebody put 4y, and then they just put that there because they put it too far in. But anyway, that's not a big deal. GCF should not be a problem. So what about this here? You can do it, Jeff. Maybe I can. Yes, I can. Does anything come out of everything? No. So this is not a GCF problem, but it's close cousin, right? It's got 4 terms, so what are you going to try to do? Grouping. Group. Cool. So out of here comes a 4. And out of there comes a X. And you know you're on the right track, or you know this is doable because these two are the same. I always get people to get something like this, and then somehow they do a next step. And normally the next step is this and this and that, and just throw it all in there and pray. Right? The next step doesn't make a damn bit of sense unless they both have the same thing, because it's really exactly the same thing we did up here. I can't take anything out unless they have something in common. And these both have x minus y in common. So if I take an x minus y out there, I get 4 plus x.
It doesn't matter what order you put it in, right?
Doesn't matter, you're right. This times this is the same as that times that. Doesn't matter which order you multiply it. That should be old news. Should be. Okay. All right. So what about the kind of problem we normally think of? The classic factoring problem is the trinomial. Right, this guy. Let's see what's in front of me. This one's not too bad, right? Should not be. Yeah, you know it's going to come from a binomial times a binomial. You know x squared has got to be. So the only real question is what numbers make these two things work?
2 times 8.
Yeah, they got to multiply to be 16, they got to add to be negative 10, because that would come from the addition of the two middle terms. Right, I'm going a little quickly because this should be reviewed. So I get 8 and 2 to make 16, and they both have to be
Minus.
They have to be the same sign to add, multiply to be positive, so they have to be minus to add to be negative 10. Whew. So real quick, if this actually would have been equals 0,
Subtract 16.
yeah, x equals 8, or x equals 2. Once you factor a problem like this, if it equals 0, if it was equal to 0, I can't solve for x, because I can't even put these x's together. So I need another way to do the problem. The other way to do the problem is to say, if it was to a first power, it's easy. So let me break this second power up into 2 first power problems, and I got 2 little dinky problems. Awesome, right? So when I have a problem that has a higher power in it than 1, I factor it, and then how do these equal 0? If either one of these is 0, the product will be 0. Right? So either x is 8 makes that 0, or x is 2 makes that 0. Okay, maybe. Now what about this guy? That's a little bit worse. I love it. I don't call it that really, but master product. And I honestly don't understand how that necessarily helps, to be honest, but if it helps you to write it, if you have any idea what I'm doing here, that's awesome. If you don't, that's also awesome. Right? The idea here, the reason this is harder than this one is because here this just had a 1 out front. So I know it can only be x and x. My whole purpose then is to find these two numbers. Here it could be 4 and 1, or 2 and 2, or 1 and 4. You know, there's more than one way to kind of break that up. So the way to do this, I call it, it's not just me actually, it's the way I was taught. It's called the Surefire Method. Sweet baby Jesus of fire. Surefire Method. That's still, her 15 minutes are definitely up, but it's still kind of fun. The way to do this is to multiply 4 and 6. You've got to take that 4 into account. And we actually do that up here. What's 1 times 16? 16, and then I find factors that work. So here, 4 times negative 6. And then my next step is the same as it was up here. What two numbers multiply to be this and add to be this?
Negative 8 plus 4.
I like it 8 and 3. They have to be opposite signs, so they're 5 apart, it makes sense. 8 and 3, and of course, which one's got to be negative?
8.
To make it a negative 5 at the end. I love it. And then the next thing I do, and to be completely honest, this is not the method I use. I use a method called Texas Slide, which is a little freaky, so if you want to see it, I'll show it to you. But some of you guys are like, yeah, but it's a little freaky. You got to be really decent with numbers. The next thing here, the really nice thing about this method is, what's the easiest form of factoring really is grouping. Because it's just a couple of GCFs. So the reason I can't do grouping on this is because it's only 3 terms. But this step tells me the way to break this middle term up so I get 4 terms that will work. There's a lot of ways to break up negative 5. It could be negative 7 and 2 or negative 6 and 1. But only negative 8 and 3 will make the grouping work. So 4y squared minus 8y plus 3y. See, those together make negative 5y. So now I can do grouping on this. Now, if you have a different way you like to do this, a master product is basically the same thing I just did. It's just a little bit different organization. Trial and error. If you want to try something and if it's a mistake, you do it again. If you have some other method you use for this, continue using that method. This is really for people that need somewhere to kind of start, because this method always works. That's why it's called Surefire. Just always the exact same steps. Yeah.
Is that the same thing as the AC method?
Sort of. Yeah, it is. Yeah, A, C, where you product. Yeah, exactly. Yeah. And then, what do you get when you group this? I'm just going to do it very quickly. And then this is the same, so I know I'm on the right track. Bam. And again, so if you have another way to do that. Anybody, all right, here's where I got to be careful. Anybody use a method called bottoms up? Of course, some of you guys are like, well, not with factoring tests. Anybody use a method called bottoms up? Anybody ever heard of that?
Is that the one where you just do all the multiples? Or?
No, but I like that. That's fine. All right, there's a method you use, and to be honest, I always forget exactly how it's set up, where you just divide by something, and then you reduce, and then just numbers come out of nowhere at you. That is not the method I want to see, because if you can explain to me why that method works, I'll let you use it. That method kind of hides all the math. So if none of you have heard of it, that kicks ass. Do it that way, you're fine. All right? If you got another way you do it, you might want to run it by me so I can see what it is. Okay. So GCF is always your first step. If there's 4 or more terms, you do grouping. If there's 3 terms, it's either a thank God problem where you just got to figure out the 2 numbers that work, or it's a, oh, okay, well, shit, a little bit more to it, but still the same idea. You guys kind of with me? And if it's 2 terms, it could be one of 2 things. Squares or cubes. And we've already talked a little bit about both of those. Okay. So how many terms there? 2 terms. So it can only be squares or cubes. Maybe it's GCF. Any GCF? No. So it can only be squares or cubes. It is certainly not cubes. It's squares, because I can cut everything in here. I can cut it in half, right? Multiplicative. So the beautiful thing is, I don't care how much crap I throw in there. If it's a squares problem, it's always a thank God problem. Because it's just going to be cut it in half. So what we go here? 5W a squared. Just cut it in half. Half there, half there. Minus plus, or plus minus, however you feel. And then cut that guy in half.
4B5.
4B5, 4B5. I mean, that's the thing about squares. It's just cut everything in half. Because when you multiply it together, incredibly enough, you're going to get the whole thing back. Right? If you cut it all in half. Yeah.
Where are your 5 and your 4 coming from?
Cut 25 into 2 parts. 5 times 5. 16 is 4 times 4. So that's perfect squares. And they have to be exactly the same so that the middle term cancels. Minus 20 blah plus 20 blah. Right? So I don't want to make 16 8 and 2 because then it won't be balanced in the middle. So that's why squares work the way they do. Cut everything in half, minus plus. They're all symmetric. They're all the same, so the middle terms go away. Does that make sense? What about that? So if you think it's x plus 2, it can't be because you don't get 2x, you don't have a 4x in the middle. If you think it's x minus 2, it can't be because then you have a minus 2. So it's prime. I like it.
Equals 0.
Prime, at least over the reals. All right, I don't have to say that yet, but prime. If I was letting you use complex numbers, you actually could do that. We're going to learn that later. But right now, this is prime. I cannot factor a sum of squares. And really, think about it. That minus lets me make these opposite signs, which lets the middle term go away, right? So if that's a plus, I can never make the middle term go away. They have to be the same sign. That is why I can't factor a sum of squares.
What do you mean by middle term?
So, do you notice how this almost looks like that, except there's no middle term? Which means the middle term here would have to cancel. That's why this worked. The middle term canceled. There is no middle term in the problem. So any answer I think I get, the middle term better cancel.
So you solve, let's say, to check your work, you just solve that.
Yeah, you just multiply back out. How do you solve any factoring problem? You multiply back out to see if you get back.
Cancel the middle, and then you'll get those.
And then you get just the front end and the back end. So this guy, you can never make the middle term cancel. To make 4, it's got to be both positive 2 or both negative 2. But then you always pick up, there's 2x plus 2x, I get 4x middle term. So that can't be the answer to this, because it's got a middle term. Same problem here. Prime. There is no way to factor that using real numbers. Yeah.
So every time it's positive, is this problem says
Sum of squares.
Oh, sum of squares.
Can't be done. If I had this problem, though, that's fine, right? So x cubed plus 8, how do I do that? Little dude, big dude?
X.
Yeah, this is xxx. This is 222. 1x, 1, 2 plus. The other 2 x's.
X equals minus.
The other 2 2's. And the middle term has to be minus 2x. The middle term is always the product of those two. Right. I went through that a little fast because we did talk about that the other day. Right? So let me give you this. Let me see what you guys think about this. This sheet is my attempt to both have a quick outline and a full explanation. So it's a little bit wordy. But at the very top is your quick reference guide. And then it fully explains all the procedures. You kind of with me? So if you don't like this, you obviously can use it for scrap paper. If this is helpful, that is good. Oh, good. Okay. Let me give you guys several factoring problems to try out, and then we'll call it a day. Oh, before I forget, we will have a quiz on Monday up through section 9.3. So in the white book, 9.2, 9.3. In the blue book, I think it's, I gave my last one away. Chapter 2 and chapter 3, those first couple. 9.2 and 9.3, yeah.
Can I have one more? It's like cut off.
Oh, yeah, yeah. My printer likes to mess with me. Alright, so here, you guys try these. You need one more? I'll be lazy. Here, that's it.